Let's go ahead and build this out. So we've got class CL product, and I'll just abbreviate it. And so we've got the initialization of that class, and we're going to have the name, the quantity, and price. So strn int quantity and fl price. Okay, so those are the things we're asking for it. Now we're going to set up those variables. Self dot strname equals strn. Self dot int quantity equals int q. Self dot fl price equals flpr. Okay. So let's say we also have this method called sell product. And all it's going to do is say you sold some self dot str name. We're not actually going to have it do anything with the inventory. It's just going to be real basic. So now I want to create a fruit class, a child class using CL product as the parent. I'm going to create a fruit class as a child here. So I'm going to say class CL fruit, and this time I'm going to put something in here. This is new. We haven't done this before, but you'll notice the first thing I do is I say that this class is going to be based on the CL product class. Because I am requiring data for that product when it's instantiated, right? And that initialization method, I am requiring a name, a quantity, and a price. This class is going to require that also, because I can't create a child class of a parent without requiring the same things that the parent does. So inside here, I'm going to require the same things. str name, intq, flpr. Super dot init, and we want to give it those three things. strn, because those are required, intq, and flpr. So it's going to, first thing it's going to do after I create a fruit is it's going to pass these three back to the initialization. I'm explicitly calling super.initialization, which basically says, here's the information you need to create the parent class. Print, you added a fruit, strn. Okay, so we're going to do that here. And in this initialization class, I'm going to say product, because I want to show you something. And that's all I'm going to do. I'm not going to create anything new yet. So if I create a class called CL fruit, you'll notice all it's doing is instantiating the product and then saying you added a fruit. So if I say ob fruit equals CL fruit, and then I'm going to say apple 10 and 50 cents. That should not all be a string. There we go. Okay. So now, when I run this, all it's going to do is create the instance of the apple, which turns around and creates the instance of the product. So if I run this, notice it triggers. I'm not explicitly creating the product. What I'm creating is a fruit, which then creates the product. Notice it says you created a product first, right? And then you added a fruit next. But now, through inheritance, I can sell that product if I want to. Okay. So even though the apple or the fruit class doesn't contain sell product, it does by inheritance. So it retains that through inheritance. Now let's add another thing to the actual fruit. So fruit has a type. Okay. And the type is required for the fruit initialization, but it's not required for the product initialization. So what I'm going to do is I'm going to say self.strType equals strType. So now the fruit has a property called type that the product doesn't have. And it's a string, so I can say like red delicious. Okay, so when I run that, I can use that here, but it doesn't belong up here because this type only belongs to that fruit. So I added the fruit, red delicious. So that extended that parent class by adding a type to it. Now let's create one more thing. Let's create one more class here. Class CL flower. That's also created using CL product as the parent class. So once again, we've got to use the initialization because it's required for the parent. Index INIT. There we go. We've got self. We've got strn. We've got intq. We've got flpr, and we will do str color for the flower. Okay, so once again, we have to call the super initialization, which initializes the parent class with the appropriate data. And then I can say self.strColor equals strColor. And then maybe I have an F string here where I said you added strColor, str name. Okay, so there we go. So now if I want to, I can say object flower equals CL flower. So I'm creating an instance of that. Roses, and roses are what, like $50 each now? Good times. And give them a color. Let's go yellow on the roses. Okay. So now when I run this, once again, every time I add every time it instantiates the product, it's going to let me know by doing this. I probably wouldn't do both of those printouts if I was really using this because it's a bit redundant, but I want to show you that each time I'm doing this, the first thing it does is it calls the super initialization, which brings in all of the inherited things. And then I am adding the color and printing out the specifics of the flower thing. So you can see added a fruit, apple, red delicious, added yellow roses. But you can see both the object fruit and the object flower have the cell product. So I sold some apples, I sold some roses. They both have the cell product method inherited from the parent class. Okay, so that is an example of how I would use a parent class to establish some things, and then it makes it easier to create the child class because I don't have to repeat those things for both the child and the parent because they have those things in common. So I can create lots and lots of child classes from that one parent class, and it inherits all of those things from the parent. Okay, so I know it's a little confusing, but hopefully the exercises will help you with this week.